Alrighty, what's up, my loyal YouTube audience? Here's what we've got in store. This is kind of the totality of what we're going to do in the video. This is the stuff that got requested. I tried to lump some of it together to make this a little bit more condensed. But let me start off with some of the problems that didn't fit as nicely and weren't as suggested. So 1, 10, 12, and 15. I'm just going to kind of breeze through on here what we're looking at. On number 1, most of the questions I had today revolved around this 60. So that 60 got multiplied through because my goal was to eliminate all of those fractions. Now, I know that 12, the first denominator, is a factor of 60, so is 3, so is 15, so is 5. When you multiply through by a number where the denominator is a factor of that number, you'll end up canceling out the denominator and ending up with all whole numbers. So you'll notice after I multiplied by the 60, I had 10x minus 80 equals 16x minus 12. So I succeeded in eliminating all my fractions. You could have multiplied through by just 15, for example, and that would eliminate the fraction with 15 in the bottom, with 5 in the bottom, and with 3 in the bottom, because all those denominators are a factor of 15, but the 12 would have remained. With 10, I didn't know entirely which part the person was referring to. But in general, the equation writing that I saw today looked pretty good. I would think of it as begin value. Wait, can I write on this? Oh my gosh, I can write on this. Begin value. So I began with 4650 goats, and then my rise over run would be every 2 days I lose 3 goats. So I can, oh my gosh, this is so cool. So I can call that negative 3 over 2. Because in a graphing situation, I would go down 3 goats and run over 2 days. So down 3 over 2. The other way to think about it is like if I had this, I'd be losing 3 goats every day. But I want to lose goats at half that rate because it takes me twice as many days as 1. So I divide that rate by 2 to make it half as fast. The other question I got a little bit is what happens here? Well, after 5,000 days, I am very, very deeply out of goats. I have negative 2,850 goats. So at that point, I'm out of goats. I have 0 goats. You cannot owe goats in this kind of a context. Goats cannot run away from you to the point where you owe goats. Continuing, we need 12. Oh, and on the graph, you don't have to go by perfect numbers. Just make sure you get up as high as you need to. So I knew the highest my goats would ever be is 4650. So I just went by 500s because that got me past 4650. For 12, 12 is a little bit weird. The tendency of most people would be to try and use N and D and build a system of equations, which would work fine. But the key is that the two variables can be related to each other. We know that he has 4 more nickels than dimes. So his nickels is 4 more than the dimes. And then when we start talking about the amount of money in his pocket, we could write this 5 cents per nickel plus 10 cents per dime equals the 125. And then this is kind of the key. This right now is unsolvable because there are infinitely many solutions because like there are 2 variables in the same problem and we only have 1 problem that's helpful there. So instead what you'd have to do, oh no, can I not go back? Okay. Instead what you'd have to do is input this for nickels. So it gets a little bit ugly. Kind of long story short here would be because you know he has 4 more nickels than dimes, if you can turn it all into 1 variable, do so. Moving forward, 15. Main question that I got asked today is from people that were doing this. Begin value of 13, increased by 15 inches each year, equals begins at 4 feet, raises 10 inches each year. Here's the problem with that is you're combining feet and inches, and you can't do that. So the first thing I did was I turned everything into inches because then all of the measurements are on a level playing field. Okay, those are the 4 questions that didn't really fit nicely into any sort of category. I would encourage you to email me if you still have questions about those. I can explain them in more detail for sure. But I just don't want to take too much time on those. Okay, so now let's start digging into like the three big topics. So big topic number one, average rate of change. Big topic number two, horizontal and vertical lines. Big topic number three, system of equations. If the only other thing you're stuck on is domain and range, I would encourage you to go back to the other video I posted in Schoology called domain and range, because building that whole thing, I wouldn't be as in depth here as I am there. Okay, let's talk systems of equations first, because this one's pretty quick. The only real issue that I'm seeing pop up with consistency is that people think equaling 0 means no solutions, and it doesn't. Equaling 0 is just like equaling 2 or equaling 3 or equaling 4. It is just another number. So when I multiply here by 1.6, the value there is that I'm going to get negative 8x on the bottom. Now, if you're wondering how the heck did he just pull 1.6 and drop it there, here's what you can do. I knew that I wanted negative 8 for the x value because then we have opposites. So if I want negative 8 and I have negative 5, the multiplying factor I need is just those divided. It's what you want divided by what you have that gives you what you can multiply by. Continuing, if I drag this top equation over, we get this. And now I can add these equations together to eliminate a variable, because we know when we eliminate a variable, we're left with one variable left. Here it's the y value, and we can solve for that y value. Now, this is the situation where people are saying no solution, but that's not true. If we divide by negative 12 here, we can get y equals 0. That's totally fine. If we had a graph and the 2 points or the 2 lines intersected when y was 0, that would just mean it's intersecting on one of these points on the x-axis. That's totally fine. We're not going to have no solution unless we get something like this. If we have negative 12 equals 0, there's no x or y left to solve for. We just have a flatly untrue statement of one constant equals a different constant. But since that isn't the case here, we can solve for y. After we've solved for y, we're going to plug it in just like normal. I'm going to take my top equation. Instead of y, I'm going to put the y value 0. And I'm going to solve from there. So variables here, constants here, 8x minus 0, so just 8x. And then divide by the 8, x equals negative 3. So we get negative 3 comma 0. So just don't mistake x equals 0 or y equals 0 with no solution. They're not the same thing. Only if you are left with one constant equals another constant are you going to see something like that. Next, average rate of change. We addressed this in class today, but I'll just kind of keep going with it. Average rate of change is saying that you want the slope between 2 points. It is just slope formula, but people get caught up in a lot of the notation, and that makes it a lot uglier. Ooh, that's a nice thick line. Perfect. Okay, so the average rate of change from 1 to 3. There are two ways you could handle this. You could do the long, difficult, annoying way, which is to say, okay, I'll get this rate of change, then I'll get this rate of change, and then I'll average them out. And you might say that's something like, maybe that's at 15, that's at like 10, that's at 40. So you might say something like, all right, that's negative 5 over 1. And then you might say this is 30 over 1. So you could average those out. And you would have 25 over 2. Oh, this is ugly. 25 over 2. So you'd have 12.5 over 1. That would be your average rate of change. Okay, let me show you a much easier way to do that. Instead, just take the point you're starting at, where x is 1, and take the point you're ending at, where x is 3. You just need the slope or the rate of change between those 2 points. Well, it rises from 15 up to 40. That's a rise of 25. It runs from 1 over to 3. That's a run of 2. I'm done. That was the entire problem. That is the average rate of change from 1 to 3. The key is to get the starting point, to get the ending point, and plug them into the formula to get rise over run. So I would say my initial point is 115. My ending point was 340. And then I'm doing slope formula. 40 minus 15 over 3 minus 1. Y2 minus Y1 over X2 minus X1. If you want to turn that into 12 and a half, be my guest. On the next one, same idea. It just looks a little bit different because it's in table form. All we care about is the first point and the last point. So the first point is where X is 1. And we want the average rate of change of all of the X values between 1 and 4. But instead, we're just going to take 1 and 4. Because whether it goes up, down, sideways, whatever in the middle, it has to get from the starting point to the ending point, and that rate of change is going to be the average of all of these other rates of change combined. So we're going to do the fast way, and we're going to say our first point's 130, our last point is 450. Plug it into the formula. Y2 minus Y1 over X2 minus X1. 20 over 3. I'm done. That's the whole problem. Finally, it can be given to you as an equation. So same idea. I'm going to get the first point and the last point, and I'm going to put them in slope formula. The difficulty is when it's as an equation, a functional equation here, we have to plug these values in to figure out what is the first point and what is the last point. Because I know I've got -1 something, and I know I've got 2 something, but I don't know what those somethings are. What I did, because some people in this situation just kind of get stuck and start flailing, I threw this on a graph. This is the graph of 3x squared minus 4x plus 1. I threw it into Desmos. So when we're looking for the average rate of change from -1 to 2, we're looking for the average rate of change from this point here, -1, 8, to this point here, 2, 5. I just saw it. 2, 5. You saw it. So from -1, 8 to 2, 5. Well, you don't have a graph normally, so here's how you can get the 8 and the 5. You plug in this x value. So instead of x, everywhere, use -1. So we would have g of -1. Notice I even replaced this x with a -1. Is 3 times -1 squared minus 4 times -1 plus 1. So g of -1 is 3 times 1 plus 4 plus 1, which is 3 plus 4 plus 1 is 8. Oh my gosh, shocker. Okay, we're going to do the same thing with g of 2, because now instead of x, we want to use 2 to get the last point. Because again, we only care about the first point and the last point. We found the first point, meaning we plugged in -1, and we got out 8. So our point is -1, 8. Same deal with g of 2. We've got 3 times, instead of x, we're using 2 here, minus 4 times the 2 plus 1. So g of 2 is 3 times 4 minus 8 plus 1. So that's 12 minus 8 is 4 plus 1 equals, I for one feel shocked, it is 5. So we plugged in 2, we got out 5, so the final point is 2, 5. All right, now we have our 2 points. The only thing left is to find the average rate of change between them. Y2 minus Y1 over X2 minus X1. Notice I let that stay a -1. 5 minus 8 is -3. 2 minus -1 is like 2 plus 1. So that is 3. And I can simplify that down to -1. That is average rate of change. Get the first point, get the last point, and get the slope between the two of them, or get the rate of change between the two of them. Finally, vertical and horizontal lines. Some people were getting pretty freaked out when they saw one graph that asked for something like this, and another graph where there wasn't an x value, and so it boiled down to like y is less than or equal to 7. I want to say. Here's how you graph these. They're not bad. If it's x equals 4, you want all of the points that make that true, aka all of the points where x is 4. It's like 4, 1. That's true. 4, 2. Is the x value 4? Yes, then it's on the line. How about 4, 17. Is the x value 4? Yes, then it's on the line. So all of those points come together to make this line, and it ends up as a vertical line through the x-axis at 4. Vertical line through the x-axis at 4. If it's y equals 2, you want all the points where the y value is 2. So here's 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. And so you get this horizontal line through the y-axis at 2. The way I usually tell people to think about it is this is the only point you're going to hit on one of the axes. There are very special circumstances where that won't be the case, where it's equal where it's equal to 0. But in general, an easy way to kind of shortcut it is the only point you're going to hit is 2 on the y-axis. So bang, I hit 2 on the y-axis, and I'm never touching the x-axis because it's running horizontally. Or in this first one, it was the only point I'm going to hit on either axis is 4 on the x-axis. So there's my line. Continuing through, only point I'm going to hit is -3 on the x-axis. So this would be a vertical line. And I know to make that dashed because it is strictly greater than. It is not greater than or equal to. So then I want all of the points greater where x is greater than -3. So like x can be -2, x can be -1, x can be 4. All of those are fine, but like x cannot be -4 because -4 is not greater than -3. Okay, y is less than 1. I know it's going to be dashed because I don't have the equal to. I know I'm going to hit 1 on the y-axis, and I'm dashing through here. And I know y has to be less than 1, so y can be 0, y can be -1, y can be -2, -3, -4, but y cannot be up here because those y values are greater than 1. Now, a couple of systems that work like that. X is greater than or equal to 2. So there's my first line. And then, crap, I just drove straight through a second. And then y is less than 3. Y is less than 3. So dashed, hitting the y-axis at 3, it's got to be less than that. So my solution set would be here. Sorry, that is absolutely repulsive. Please rewind and watch that again, but maybe don't because you'd just be watching me do that disgusting disaster twice. Okay, x is less than or equal to 0. This is the one situation that I said is a little bit weird. It's tough to have a shortcut for this. Here's why. If you have x is less than or equal to 0, you actually have this line, this vertical line through the x-axis at 0. Some may call that the y-axis because it is. But the idea that x equals 0 is the y-axis and y equals 0 is the x-axis is incredibly confusing to most people. So I don't want to try and lay that on you. I would think of it more as like, think of some points where x equals 0, because that's what we're graphing. Think of some points where x equals 0 is true. Here, is x equal to 0? Yes, it is. Here, is x equal to 0? Yes, it is. Here, is x equal to 0? Yes, it is. So if I can just connect those points, I'm going to get the point, or I'm going to get the graph I want. And I want to be less than or equal to that. So I want all the x values less than that. And then lastly, let me maybe change the color. Should have done this a while ago. X is greater than or equal to -2. So I'm hitting -2 on the y-axis. And I want greater than or equal to that. So that my solution set would be in here. So colorful and fun. Okay, that is everything that was requested multiple times. What I would suggest if I were you is pause the video, try this recap, or at least get an expectation of what you'd think you'd see when I solve this out. And then I'm going to solve this out. Okay, add these together. You get 0x because 1 plus -1. So you would have -4y equals 0. We know, because we are all incredibly big brain, such a large brain, that y equals 0 is not no solution and that those are different. I can then plug this back in and say x minus 0 instead of x minus y. X minus 0 is 4. Uh-oh. Uh-oh. Okay. x minus 0 is 4. Uh-oh. Okay, I'm going to try and maybe delete some stuff. Maybe we've got too much stuff. Okay. Okay, interesting. Okay. Maybe now I can write things. Let's try it. Okay, x minus 0 equals 4. So x equals 4. And so our answer would be 4 comma 0. So again, y equals 0 is not no solutions. Next, graph x is greater than negative 4. So I'm hitting negative 4 on the x-axis, dashed because it's just greater than. And I want y is less than or equal to 1. So I'm hitting 1 on the y-axis, and I want to be less than that. And so this would be my solution set. And then lastly, find the average rate of change of f of x over the interval negative 3 is less than or equal to x is less than or equal to 1. So I am getting f of negative 3, which is negative 3 to the second minus 1, which is 9 minus 1, which is 8. So I know that when I plug in negative 3, I get out 8. Oh, snap. There's the first of the only 2 points that I care about. Next, we need f of 1. We got 1 squared minus 1, which is, let me just be precise. Then we've got 1 minus 1. And for you academics out there, that's 0. So you plugged in 1, you got out 0. So now we need the average rate of change between the only 2 points we care about. So we got y2 minus y1 over x2 minus x1. Notice I left the negative there. That is negative 8 over 1 plus 3, aka 4. And your answer would be negative 2. I hope this was helpful. Sorry for some of the tech difficulties that happened. Feel free to email me if there's still lingering questions, and I'll answer them as quickly as I can. Good luck tomorrow. Study a lot. Feel free to send me emails. I'll be in meetings most of the day, so you might be giving me something to do. Good luck. Keep me posted.